Good afternoon and welcome to today's webinar from Timber Development UK. Timber, Moisture and Technology, Insights from Llama Croft. In a moment, I'm going to be handing over to Seb, Janna and Ben to hear all about this inspiring project. But just before we start, I'm going to say a couple of words about Timber Development UK. TDUK was formed in 2021 from the merger of the Timber Trade Federation and TRADA. This makes us the largest supply chain body in the UK. We span everyone from sawmill to specifier, craftspeople, architects, structural engineers, and everybody in between. If you work with timber, you really do belong with us. Here you can see our three missions statements: to connect the supply chain, lead best practice, and accelerate a low carbon future. And we achieve these goals via lots of outputs. There's webinars like this one. There's our magazines. You can see Designing Timber there, one of our two flagship magazines. The other one is Supplying Timber for the supply side. Designing Timber can be read on our website, and you can read lots of stories of fascinating timber buildings, lots of CPD, lots of news on guidance, regulations, and everything that a timber designer needs to know. There you can, next to it, you can see moisture management during construction. That's one of many guidance documents you'll find on our site. Some are free to all, some are member only, but that one in particular is a really essential document for anybody engaged in timber buildings. But you can explore our knowledge library to your heart's content, and you'll find plenty of really useful documents there. Another example of the things you'll find in the knowledge library is just there, using SIPs. That's one of our many timber knowledge sheets. These cover all aspects of timber design and construction. And there you can also see an example of one of our case studies. That's Cotto House, an interesting modular timber building. But we have case studies on all sorts of interesting timber buildings, whether they're residential, educational, commercial, or infrastructure. You name it, you'll find some great examples there. There you can see a close-up of our latest issue of Designing Timber magazine. There's Rafter Walk, really interesting bit of infrastructure in London's Canada Water. We actually have a case study on that and a webinar, so do investigate us further for more info on that. An awful lot of our resources are free to all, but there are also a lot of member-only resources. So we would love you to join us if you're not already a member. It helps us to put on great things like this webinar. Helps us put on things like the UK Timber Design Conference, our annual conference for timber design. You can find out everything you want to know about joining us on our website. So now I'm going to hand over to Janna, the designer of Llama Croft. Just a little bit of housekeeping. If you go to the bottom of the screen, you should be able to see a Q&A box. So do open that and ask away with any questions you like as we go. There will be time for a bit of Q&A at the end, but you can also pop a few questions in that box as we go. So now over to you, Janna.
Thank you very much. Right, I'll just start sharing my screen. Sorry. Okay. Is that all good?
Looks great.
Okay, so yeah, thank you very much for having me. I am Janna Laan Lomas, and yeah, so a little bit just about my background. I work with an architect's practice called Grain Architecture, specialising in natural materials. So I'm quite a sort of advocate for natural materials generally, and we do a lot of projects with them. For all sorts of reasons, from resource depletion through to carbon footprint and healthy, non-toxic materials and building. But we are obviously focusing on Llama Croft, which is my sort of dream house, which I've been lucky enough to see come to fruition. It's still on site, so we're not quite finished. I'm sat in the kitchen at the moment. There's a few things going on around me, but I'm going to talk you through a little bit about how the building is made, the materials, how the materials work specifically with moisture, and just sort of give you a bit of a slideshow of where we're up to so far with the project. So just starting at the beginning, this is us buying the site 3 years ago. And there was a little old cottage. After much deliberation, we decided to dismantle the cottage and reuse the materials rather than retrofit. I'm not going to get into that now, but more could be said on that, obviously. And we're very lucky. We've got a lovely site, southwest facing. And we also discovered very early on that we have amazing clay. So we're based in Hereford, and Hereford has this really, really gorgeous red clay. And so, yeah, we tested that out with making our own clay plaster. So we started off by actually building a little tiny house. Here it is, which we lived in, are still living in 2 years later, throughout the build process. But this was a test ground for the clay plaster, and we were really happy with it. So we decided we'd do that in our house. So that's one of many natural materials we've got in the house. I mean, I'm a huge advocate, as I said, of natural materials generally, so I don't have necessarily one favorite that I'm pushing more than others. We've chosen a system for various reasons, but yeah, we've tried also to include as many different natural materials as possible in the house. Partly because we just want to like show them off and share as much information as possible about them. But they also have really good properties, a lot of them. So the system we've chosen, for various reasons, a large part of the reason was timescale, to be honest, speed of building, but also quality. And yeah, we decided to go with a prefab timber panel system. And that is basically filled with cellulose insulation, which is old newspaper, and then wrapped externally in wood fibre board. The floor, walls, and roof are all made like that, but the floor is not. The floor and roof are not prefab panels, but they're sort of the same idea. And then the walls are prefab panels. This is a section through the floor. So we're just showing here that we've lifted it off the ground, away from moisture. We've got a well ventilated space under the floor, and that means that we don't actually have a damp proof course or a damp proof membrane, as it were. So we haven't got any membranes, really. I'll talk a little bit more about airtightness membranes in a minute, but yeah, no vapor membranes or damp proof membranes. Here we've got the screw pile foundation, a glulam ring beam, and then on top of that we've sat the joists for the floor and then the structure for the walls. So here you can see the structure for the walls as well. So we've got a Larsen truss, which is a split frame, uses smaller timbers, which is great. We've managed to use C16 timbers, which is great. So they can be UK sourced. And also it means that it's more thermally broken. So another reason we went for the prefab panel system is because we wanted to go for Passivhaus certification. And we've collectively done talks on Passivhaus. So if you're interested in that, go and look there. But we basically, what that means is it's really thermally efficient, it's airtight, and it's minimizing thermal bridges. So this shows, yeah, the spaces. I don't know if you can you see my mouse? Yeah. So yeah, so these timbers are joined just with small gussets, but most of the two sides are kind of separated. And the same happens with the roof. We've got a sort of thermal bridge free eaves detail here shown, and yeah, again, this shows the sort of separation. And then we've got the wood fibre board wrapping all the way around the outside in one continuous layer. And that's a really good that's a really good way of reducing thermal bridging generally. But we've also reduced having any timbers fixed through or penetrating through that layer to create the eaves overhang by doing this. You also might notice we haven't got any membrane on the roof, and that's also to reduce plastic, but we don't need it because of the wood fibre board. This is a type of rigid wood fibre board which is relatively hygrophobic. So what that means is the water, if there is any rain that comes through, it runs off of it and doesn't really soak in or penetrate. So it doesn't need a membrane. And this does only work with roofs of a certain pitch, so not for flat roofs or low pitch roofs, but with this it works really well. So that gives you an overview of how we've made it. This is a section through, and I'll talk a bit more in detail of some of the materials as we go through now the progress of the actual build. So we started January 2024, just about January, February, with a lot of mud on site. So a lot of groundworks were going on site. Meanwhile, the prefab panels were being built off site. And then by March, I think we still had a lot of mud and rain, but the foundations started going in, the screw piles. And these are wonderfully simple. I think Seb might talk more about these. Yeah, so they're very simple. They're only actually 1.6 or 1.8 meters long. And yeah, they simply screw in and hold the house down. So that's it from above. Seb's got a drone, so we've got some lovely footage from the sky, and you can see there the I can see. Can you see that zoomed in? Yes, awesome, that works. So yeah, so we've got you can see all the screw piles there. They had to actually dig slightly around them to just get the fixings for underneath into the glue lam, but and a land drain as well, just to make sure the drainage was there. Oh, no, there we go. So then they fixed the glue lam ring beam on. There it is. And then we started with floor joists, the rigid wood fiberboard on the underside, which was a fun job for someone to do the fixings. And then the pro passive board. So this green board is the only real sort of plasticky bit in the building, I'd say. And it is also the least vapor open. So one of the major drivers for using natural materials is about the moisture management properties of them. And basically, I'm going to just assume a level of knowledge here and explain that moisture will always, or water, vapor in the air will always be attracted to cold surfaces. And in this country, primarily, that means in winter, the outside is colder than the inside. So the outside is attracting more moisture generally because it's colder. So we have a sort of direction of movement. And that means that we want to avoid having a surface which can trap moisture on that cold side, on the cold surface on the outside. So we have a vapor permeable buildup on all sides from the airtight layer outwards, but the airtight layer itself is actually not particularly vapor open. As you can see, there's this film, this green film, which is adhered to the OSB boards. The boards are needed for racking strength anyway, and they're already not very vapor open. So vapor it's not vapor open and closed. There's a sliding scale, vapor permeability. So it's not 100% closed, but it's also the OSB boards are relatively closed compared to the other materials we're using, which is the cellulose, the natural wood and wood fibre board, and lime render. So yeah, moisture, you can see doesn't really, there's a lot of moisture there. It was raining whilst we were doing this. But yeah, these panels were great because they go up and very quickly. And then we got to, this was last summer, we got to starting to wrap the outside with wood fibre board. And there you can see the nice joints. This is quite thick. I think we had 100 mil on the roof and underside of the floor of wood fibre board, and 80mm on the walls. And then the actual thickness of the insulation was 300 for the roof and floor, and I think was it 340 for the walls, I think, something like that. So yeah, that went on, and then no membrane, but there you can see the lovely slates going on, reclaimed slates, of course. And there's Seb putting in some moisture meters, which he's going to talk more about. But this has been a really interesting thing to have data from. Windows and doors went in. Here you can see that eaves detail, again, the wood fibre board wrapping around. And yeah, all the timber panels slotting together. Just some nice shots there. We started the lime render on the outside, so the lime render goes straight onto the wood fibre board. Got the base coat, scratch coat, and then the top coat, which has this, it's a pigmented top coat, so it's got a lovely yellow colour. And there it is. It doesn't look very different now, really, but we're still landscaping the outside. So then at Christmas, we basically started work inside after they finished insulating it. So here you can see them, they cut the holes and pumped with the machine to, it's like a vacuum cleaner in reverse that sort of pumps the cellulose insulation into all the cavities in the wall, in the cassettes. And then they tape over the holes again afterwards with this airtightness tape. And that's the cellulose close up. Then we also started on the internal walls. So basically what I've talked about so far is the external build-up from sort of the airtightness layer outwards. And that's really important because of the moisture wanting to move towards the outside where it's colder generally. So it's important that that's managed well, and that if there is a layer that's less permeable, that's on the warmer side rather than on the colder side, to avoid any moisture being trapped in the wall. But on the inside of this airtightness layer, we've then used a whole myriad of lovely breathable materials, which are also, many of them are hygroscopic, which means that goes one step further than breathability. So it means they can actually manage the indoor humidity by sucking in moisture when there's excess humidity and holding on to it, and then releasing it again when the humidity levels drop. And wood is very, very good at that, but also clay, and we have this lovely clay. So we've ended up with a lot of clay-based materials and clay plaster. This is showing light earth, which is a type of insulation with straw sort of tossed in clay slip and then tamped into the wall, a bit like hempcrete. And then you remove the shuttering and it dries out. Great surface for plastering. And this provides us with insulation, both thermal and acoustic, but it's an internal wall. And we also had quite a lot of waste timber, which we turned into lath. And this was a fantastic way of using up the waste from the site, because the building site generates a lot of waste timber. And yeah, we've reused as much as we can in various different ways, but lath was a really good method. We've also used reed matting to plaster onto, which has been great, particularly onto the internal OSB walls. And there we are, mixing up some lovely red clay and putting it on. And that's been, yeah, really, really good at this sucking in the moisture, managing that indoor air humidity. And that's the kitchen where I'm currently sat, looking a bit different. That was March this year. And Seb did the floor. We've come a long way. We're also using scraps to including wood wallboard, which yeah, is just for window reveals. We have had lots of volunteers come and help with clay plastering, which is great. We quite like a rustic feel, so it's been quite a good opportunity to get people involved in that. And here you can see a bunch of volunteers. They've just put clay slip on the lath, which helps kind of break the surface of the timber a little bit in terms of moisture. So when you do put the clay plaster on it, it really sucks it in and keys really well. And there it is plastered. We've also used hemp fiber insulation in all the intermediate floors, and that also is very good at managing moisture and also very good at acoustics. It's a lovely material. This is just a nice picture of clay plastering. I just really like this picture. Bringing out that lovely red colour in the clay. We've also used earth in the floor. So we've actually got this, so we've got surface cavity all the way around, which is normal, but we've also got it on the floor. And what that means is we can fix down the floorboards into the battens, not penetrate the airtight layer. We also have this void between the battens, and I decided, well, let's fill it with clay, because actually that will help with both moisture and temperature, so we can use that as a bit of a thermal store. Here you can see the sun hitting it, and it beautifully holds that solar gain, that warmth, and yeah, it's really nice. So still working our way through it. I'm almost there now. Seb's been doing some joinery as well, and this is us this week. This is where we're up to. Still a building site, but we are getting there. And oh yes, I have to finish on the stairwell because we're in the middle of having these stairs done. So this was me plastering the top of the stairs. You can see here just the nice sort of mixture of the airtight pro passive board with airtightness tape and purple passive paint on the holes, and then this lovely earthy clay plaster next to it. Of course, it's all covered up now with clay, looking much nicer, I think, than the pro passive. And then we have this lovely staircase going in, currently built by Carwyn, who is sat in the room with me here smiling. And there he is building our stairs, which are these really nice oak chunky stairs. I just had to share that with you. They're still being built, so I can't share finished pictures, but they are looking rather lovely. And that's it. That's how the house is made. So I'm now going to pass over to Seb to talk a little bit more about the moisture meters and the data that we've got from them. I think that's your focus, isn't it, Seb? So yeah, over to Seb.
Thank you very much, Janna. Let me replace slides.
Do ask any questions you'd like to using the Q&A box, by the way. So I've seen a couple pop up, but plenty of room for more. Thanks.
Well, thank you everyone for joining us on your lunch break. We appreciate it. I'm Seb, Janna's partner, and I'm going to talk a little bit about some of the sensors that we put into the building. As Janna mentioned, some of the things that we've been doing are kind of things we've wanted to explore, and there's something kind of having like one's understanding of how something should work, and then there's the other bit of like actually having the hard data behind it to be able to show it has done what you said it was going to do or hoped it was going to do, and maybe not. Maybe there are some learning points. So that's why we've kind of gone on this kind of this journey from a data perspective. Just from a bit of scene setting, I'm sure everyone on this call is aware just how significant moisture is from a insurance perspective. There are now more losses from moisture than fire in the construction sector, and despite a lot of the research actually being around fire and not so much around water, there isn't as much guidance. Matthew shared a really interesting one that TDUK put out recently about managing moisture in construction, which I definitely recommend having a look at. but you know, it's an aspect of the construction that needs still more clear guidance on how we can mitigate, and then also demonstrate that we have mitigated those risks, because that is a really, really big part of negotiating and courting as insurance, as some would say. But from our perspective, this was more led by curiosity in the work that we do in our practices. We want to be able to advocate for these platforms, these approaches. So our house was a really nice test bed for trying out a platform that I had never used before. So I was introduced to Tector, which Ben Sharples is going to talk to you more about, the company itself. But it's a really nice, simple platform. It has these very small units. I haven't got one to hand, which you then just build into the building. The data is streamed to the platform, which you can log into, and you can run reports. It also triggers alerts if something happens, if something changes by more than 5% in an hour or so. And we have used other platforms and sensors at Architype before, but this is definitely the most kind of progressed and user-friendly one that we've come across. So this is just an image of kind of putting them into the frame. So we installed these sensors during the construction sequence on site. You can actually install them in the factory, and provided you have Wi-Fi coverage, you would actually collect the moisture data for the whole journey of the item from the factory onto site through construction and then into building use. So you'd have that whole moisture journey mapped. We had it from the moment things were on site. And as you set up these items, you kind of take photographs, you put in all the metadata about where it is, what's it connected to, is it insulated, not. And then the 3 bits of data it's collecting are the moisture content of the piece of wood it's screwed into, the temperature near surrounding the sensor, and then the relative humidity surrounding the sensor. And interestingly, this is an emerging sector. There's no quantitative guidance on where you should put them, how many you should have. It is a qualitative judgment. So we decided to kind of focus on the things that we were interested in learning from. So we've put a number through one of the external walls, so we can actually see the moisture movement through the wall. Put some in the roof and some in the floor, and also the light earth wall that Janna shared in her presentation. And I'm just going to take you through some of the kind of outputs and some of the findings that we've had to date. So in the roof, as Janna mentioned, we're really keen to avoid the use of membranes where possible, avoid insect membranes because of the plastic content and the biodiversity impact that they have. We also use reclaimed tiles. So what we were able to show from this is that the moisture content in the roof below this buildup has been exceptionally stable from a moisture content perspective, even with the very heavy rain events that you can see with the vertical blue lines on the graph. So this platform automatically draws on local weather data. And as Janna mentioned, the ground ring beam is a glulam system sat on screw pile foundations, which were a delight to get to finally use on a project. There are loads of reasons why we wanted to use screw piles touching the ground lightly, something that goes in quickly, but also it's 70% lower in body carbon. And that's not just because it's easily reusable, but the production of it has a lot lower emissions, as you can see from these EBDs. But with that ventilated space, we wanted to see how well that worked from a moisture perspective. You know, we all thought it should work, but it's nice to have the data to show that it does work. So what you can see here is 2 sensors underneath the building, in the floor build-up on the ground floor, the moisture of the timber drying out as the insulation's been installed and the building's warming up, and that timber content coming down below 15 degrees. And that's both within the middle of the floor plan and by the outside of the building. We wanted to see if there was a significant difference between those two. And this has been a really interesting insight. Actually, this is the external wall of the building facing south. So we have sensors here on the outer timber of the Larsen truss, the inner timber of the Larsen truss, and also inside the kind of like service cavity, which is the light blue line you can see here. And what we've been observing here is, as Janna mentioned, with a breathable construction, the wall is able to absorb and desorb moisture. And what you can see here in the bottom graph is the outer timber is absorbing and desorbing on a daily basis as it responds to the temperature. As the sun swings around, starts warming up the plaster, and the moisture is drawn into the cooler element of the wall build-up, and then it desorbs back. But what's really nice to see is, even though the outer timber is kind of fluctuating in that safe zone, the inner timber is completely nonplussed by this absorption and desorption that's going on a daily basis. Janna mentioned this spine wall that we have in the building where we use light earth, and we had some OSB board. And what this experiment showed is that OSB really does inhibit the drying out of light earth construction. And you can see here the moisture content racing up, and we used dehumidifiers, and then we had to drill in some holes in the OSB to draw out the moisture. But again, putting in the sensors gave us that feedback. This was an experiment. We knew it wasn't kind of an ideal kind of, but getting this feedback was really interesting in real time. And similarly from the external wall. So what this graph is showing is actually the sensors. So just before the external wood fiber board that Janna mentioned was installed, the timber frame got really wet from a series of rain events. It was a really horribly wet year in 2024. And you can see here the moisture content of the timber getting up over 60%, which is way too high for what you'd want. And certainly the last time that, not an ideal moment to then clad the building in insulation. But as Janna mentioned, with the breathability of that whole wall system, the Tector sensors were able to then show the frame actually then drying back out over the next period. And I can now happily say that it's unaffected by rain events, and it's down between a 10 to 15% moisture content now. So I just want to finish the data as of this week, and certain things have gone on kind of big journeys along the way, but everything is now between a 10 to 15% moisture content across the building. And the bottom graph is just showing you, the weather as it's the mercury has been dropping this week. We're now seeing a bit more kind of fluctuation in the fabric. And I think, Tector is, we think about it as a platform because of the moisture content, but it's also really interesting to also get the temperature feedback. So you can see here the kind of like the performance of that Passivhaus wool fabric, smoothing out the curves and the thermal responsiveness, and kind of providing that more stable indoor environment. And there we go. That's the house looking lovely in the sun, nice and dry. Thank you.
Okay, now I'm handing over to Ben.
Yeah, thanks, Seb. I shall just share my screen. Hopefully you can see that okay. Yeah, great to hear about the Llama Croft project. I've heard a little bit about it and spoken to Seb a few times, but amazing to see all those photographs and the progression over the last couple of years. And hopefully one day I'll get to see it in real life. But yeah, just to introduce you to Tector, which we're a sort of a moisture monitoring leak detection type solution. We use technology to determine whether your building's at risk, basically, from water ingress. And those are the sensors that Seb was just talking about there. They've got in the fabric at Llama Croft. My name is Ben Sharples. Formerly a timber consultant, so I've been working in timber expertise for the last 10 years of my career at BM Trada, investigating all sorts of interesting and weird and wonderful projects, whether that be for structural surveys or problems that have occurred in timber in various forms. And I joined Tector about a year ago because I like the preventative side of things. I've worked on a lot of projects where we've been called in when there's been an issue, and some of the big insurance cases actually that you've probably heard about in the headlines of the construction news. And Tector offers a solution to help prevent that and help protect our assets. So I'll delve into the presentation just to introduce you to our solution and why it's here. A little bit of background. In 2021, the government released the net zero strategy to build back greener, which is our sort of strategy to create a net zero by 2050. There's a lot of encouragement and incentivizing for the use of timber in that strategy document. And the idea being that we embed net zero into decision-making, society and governance within the construction industry. And with that released in 2025, we had the Timber and Construction Roadmap, which gives you more of a strategy to the UK construction industry on how to do that and how to use timber to improve and hopefully achieve this net zero target by 2050. We know, and I certainly know, that timber as a material is a fantastic material in construction for many reasons. It's an extremely sustainable material, or it's regenerative. It sequesters carbon, so we have a lot of sustainable benefits from that side of things. In terms of construction and timings and speed on site, it's a lot quicker to build with than traditional methods. Aesthetically, I think most people will agree that aesthetically it has some benefits. It looks beautiful. It creates amazing spaces, such as the image there on the right-hand side with a lovely glulam grid shell roof structure and a CLT exposed facades. And we're able to create amazing large open spaces as a result of engineered timber products such as CLT and glulam, or if we're using extremely strong large sections of specific timber species, like the image at the top there, which are machined structural beams. So they're extremely strong, but also incredibly naturally durable as well. The fact that there are thousands of different species throughout the world means that there are such a variety of timber that we can use, providing they're sustainably sourced. And they all have different benefits and different uses for their applications in the construction process. And I think in more recent times, and particularly in the last 10 years, we've seen a massive sort of growth in the mass timber side of things, and the usage of mass timber in the industry, as you can see by that plotted graph there, with a little dip in the growth around the pandemic period, but back on track again, that we are seeing this steep curve in the usage of mass timber. So it's definitely being accepted well, and it's here to stay. But with that, we do obviously need to understand the vulnerability side of the timber as a material. Once we do have a good understanding of that, then we can plan and build into the design side of things ways to mitigate the risks associated with it. Timber, as Janna said earlier, timber is a very hygroscopic material. So it is predictable, so it does absorb moisture and it reacts to the ambient conditions. If there's an external source of moisture or liquid moisture in the air, for instance, it can retain too much moisture for too long a period, and that's when you'll get signs or beginning signs of fungal decay developing, and which can affect the structure and damage the structure as well. Unfortunately, with some mass timber projects, the leaks can go unnoticed. So if you do have an intermediate floor or a flat roof, for instance, in a material like CLT, due to the hygroscopic nature of the timber, it will absorb moisture if you have a leak, whether that be in the roofing membrane or in a bathroom. That water gets absorbed by the timber panels, and unfortunately, if you do see signs of leakage, it can also sometimes be too late. As in the diagrams here or the pictures here, you'll see some decay around the structural connections of an intermediate floor and wall panel, which has been propped from below, and you just see some staining on the wall panel down the side there as well, as a result of some ingress there. So it can cause structural damage, it can cause mold growth, which can affect air quality, and not only that, you've got the risks of the collateral damage, the knock-on costs, and building usage as a result. And an interesting figure that stands out to me is that currently, on average, 3.3% of construction budget is spent on water ingress alone. So that is during the total construction budget. On average, 3.3% is being spent on water ingress. One of the big contractors I was speaking to recently said, well, their average is about 2%, which I thought sounded quite good, but still to them, 2% was a lot of money being spent on something that, in theory, can be prevented. So I think Seb's given you a really good understanding already about our system and how we look at data to determine whether we've got leaks, let's say. I think Seb's at Llama Croft, you're looking at the performance and the changes in moisture content of the structure and the drying times and that sort of thing. The system can be used in all sorts of different ways. This is a home experiment where I just took a block of wood from outside, just in my scrap pile of wood that's been sitting outside. It got very wet at the end of August when we had some torrential rain. I thought I'd grab a piece of that, I'll stick a sensor in that and put it in my office. I've actually got it here, if you can see. As you can see, when I installed that at the beginning of September, it was just over 20% moisture content, about 20 to 22. This is in the core moisture content, not the surface. And gradually, as it's been in my office, it's dried down. Now, the bottom graph here tells you the temperature and humidity that that block's been exposed to. So this is the internal conditions of my office. And based on that, we know that moisture content's predictable. We have an equilibrium moisture content. So based on those conditions there, we plot this dotted line here, which is the equilibrium moisture content. That's where the moisture content of the timber should be if it's kept in those conditions and there's no external source of moisture. And as you can see, within a couple of weeks, my little block of timber has reached equilibrium moisture content, and it's following that dotted line very nicely. If I put that into a real life project scenario, this is a project where we have sensors installed in a CLT flat roof. The panels, the sensors are actually stored in the factory, which is around about this stage here. The timber's nice and dry, it's on the equilibrium moisture content line, no problem, and then they get installed on site, unfortunately in the middle of winter, which for some reason seems to happen with timber structures. We install them in the middle of the winter, and it's got very wet. Now this top line here showing 100% moisture content isn't necessarily the true core moisture content of that timber. That's just showing that there is liquid water on the sensor. But what is the true moisture content of these more stable lines here that we can see? So it's got wet, the waterproofing membrane has gone on, and now the timber is slowly starting to dry out. We know that 20% moisture content is the decay threshold, so we want that moisture content to be below 20% for it to be safe from the development of decay. Unfortunately, this one is taking quite a long time to dry, and we're working with the project team on this one to get some expert advice in, just to mitigate any problems that they might have. But they have a clear view on what's going on there in their roof. And I'll take you through a few case studies of ours. This is a project in Copenhagen. We're a Danish company, so we have a lot of projects in Scandinavia generally. But it is an organisation that was building a movie theatre on top of an existing building. They got in touch with us and wanted some sensors installed there. They decided that they didn't really want to spend the money on that, and they'd take the punt on not going for that. Unfortunately for them, they did have 46 leaks during the construction period into the original building. Their initial budget of 4.3 million turned into a 16 million pound project as a result of water ingress. It hit the headlines. They took the Tector solution later on in the process. We found one leak after that, which was detected and resolved quite quickly. Another one is the Mary Elizabeth Hospital. It's in Copenhagen. As you can see, lots of different sections of flat roofs. This isn't actually a timber roof. This is a concrete flat roof situation. So we put sensors above the concrete in the flat roof environment. This basically, we're able to install the sensors as each roof section was completed. The roofers would move on to the next section and so on. What was happening is the sensors that were installed in a completed roof were picking up leaks in the roof. It was quite handy for the main contractor because the roofers were still on site, so they could go back, fix those roofs, and make sure they all dry before they carried on. Unfortunately, after 34 or so leaks in these roofs, the main contractor decided that the roofer wasn't quite performing in the way that they wanted, so they were change in the roofing contractor, completed the rest of the building, and were able to hand over that dry to their main client at the end. In the Paris Olympic Village, we installed sensors under the shower trays. This is CLT structure. And as you can see, these are all individual sensor readings here on this graph. And as you can see, in late July, last year, when the athletes started moving in and they started using the showers, one of the sensors started spiking and sent an alert to the user. The facilities manager came to investigate. He was able to see that there's a leak around the shower waste tray. That was fixed, and then the wood moisture content, so you can see, starts drying back down to where it should be. And all of that happened before 20% moisture content decay. The decay threshold essentially was even hit. So it only ever got to about 18-19% moisture content before the leak was reported and fixed. And one last project that we have to shout about, because we're very proud of it, is Notre Dame, and we have 200 sensors in the roof there. They're in the main structural roof components known as the forest. Having seen a recent BBC documentary, because there's such a vast amount of timber in the roof there. The roof is constructed using the traditional methods, and with that using green oak, so relatively freshly felled timber. And as we've talked about briefly earlier, timber is predictable. We know it's going to dry, and we know at what point it's going to get to eventually. So by monitoring the drying process of the green oak in the roof, they're able to the engineers are able to have a look at how much movement they've got left, how the structural joints and connections are going to be compromised, if there's going to be any distortion or further movement in the roofing structure, so they're able to monitor it that way. And also install sensors in quite hard to reach spaces like that 34-meter tower there. It just means that the sensors are monitoring in multiple locations, and they don't have to send the body up there every other day to keep getting new readings. So in summary, we've just launched some different sensors which have an extended battery life now, which is up to 25 years, which has been some feedback that we've had from a lot of our clients. So this not only takes us through the construction and the defects liability period and the contractual liability period, but it takes us right through the operational phase, long into the asset's life of monitoring and protection of the buildings. The idea being that we're not going to prevent risks, but we're going to pick them up, hopefully within a week. 7 out of 10 of our customers will fix a leak within a week of the alerts being sent, with the idea being for a small initial outlay, these savings in the long term will be huge. That's it from me. Thank you very much for listening.
Great. Thank you much, Ben, and thank you very much, Seb and Janna. That was great, really informative. Yeah, I mean, we've had a few questions popping up, and do keep them coming in. I see several of them have been answered as we've gone along. There are a couple of questions, asking about how the sensors were powered, battery powered, and battery life, and the like. I have a couple of questions of my own. I mean, actually, the first one that just occurred to me, Ben, as you were talking, was just if there are any kind of common leak causes that you've sort of noticed. You know, when I mean, I was thinking particularly when you were talking about particularly the roof. I think it was the Copenhagen hospital where there seemed to be so many. I just wondered if it was possible to generalize. You know, is there a standard oversight that contractors are often making that is responsible for a lion's share of these kind of leaks?
Yeah, sure. As Seb said, there's no sort of standard to say where you should put these sensors necessarily, but what we do offer is a analysis or risk analysis of a building or a project, and that will look at the sort of common risk areas, like you say about those roofs, for instance. So the positioning of the sensors will be based on a risk analysis, and that will be agreed with the client. But you're looking at, well, I think some of the main risk areas, let's say, would be flat roofs generally, and then you're locating sensors adjacent to areas where you've got penetrations in the waterproofing membrane. So you've got special seals or should maybe manual seals, dare I say it, but where it's not so necessarily tight on the seal front. And any sort of ventilation ducting and rainwater outlet, that side of things. But then you've also got to look at things like facades and openings in facades. You might have gutter outlets that get blocked or get overwhelmed in large storms, and they spew then water down into the facades. And if you've got a timber frame or a CLT structure, and the moisture can get in there in various forms, that's another area. Parapet walls are notorious because of the particular detailing that you'll find in parapet walls, and they're often located adjacent to gutters and outlets and box gutters and things like that. And you've got very intricate lapping of membranes and capping pieces and that side of things. And then particularly with CLT construction, wet rooms are what we would consider high risk. So from my surveying days at BM Trada, I've unfortunately seen quite a lot of unprotected wet rooms where it's gone unnoticed that there's been a leak under a shower tray or getting through the tiled walls or something like that, and some of the consequences can be devastating. So just a sensor there just to alert the user, just to say we think you've got a leak here, allows that inspection just to go and investigate and see what's going on.
Great, thank you. So I think I might just turn back to Janna and Seb. One thing that I wanted to ask about was the contractor on the project. I sometimes get the impression that when using biomaterials or anything that's even a small step out of the ordinary, it can be sometimes be a struggle to have convince the contractor or find a contractor that's used to working with breathable materials. So I just wondered if either of you wanted to say anything about how you found the contractor, how that all went, and whether they were experienced with using timber and other breathable materials, whether this was new to them or what.
Yeah, I'm happy to answer that one. So as I said at the beginning, so we do, as architects, specialize in natural materials. So we're quite used to kind of talking to contractors about using natural materials, and that means often unconventional materials. So it's not sort of, that wasn't a new thing for me to kind of have to stand my ground with builder. But actually in this instance, we chose the builders because they specialize in these timber frame, like the prefab timber frames with cellulose and wood fiberboard. So it's already the build up that they're used to. I think the floor was different from what they're used to, because you used to, now they've changed to doing this as the standard because they prefer it, which is great. More timber, less concrete. That was a really nice win. But yeah, it wasn't a battle to get them to use the timber, cellulose, wood fiberboard That's all quite standard. I think so. Anything from inside the airtight layer, we did the insides ourselves, so we were able to kind of use all the less conventional materials without that sort of battle.
Great, good to hear.
Who will use them, and often, like on other projects, we've been able to kind of convert builders, which is great. So they can really feel the difference in working with the material. It's nicer to work. So it's usually very much nicer to work with a natural material than a sort of toxic irritant that they might use otherwise.
Great. A couple of questions just popped up that are kind of similar-ish. One of them had asked about whether there were any issues obtaining a home warranty insurance policy. And then I suppose related, did you have to have a structural warranty on the building? If so, which did you use and what was your experience like? I don't know if you'd like to answer any of those.
Seb, do you want to answer them, or shall I?
Be my guest.
You don't have to.
Yeah, I wouldn't call the timber frame an unusual structural material. It's very standard in terms of structure. It's a timber frame. It's not there's no issue there. It's not that unusual to do timber frame, I-joist, Larsen truss. It's just putting timber frame down instead of masonry. But I think from an insurance point of view, I mean, Seb, I think I'm just going to put you on the spot here, been talking about like using the data that we've got from these sensors as a way of kind of helping insurers feel more confident in giving policies. So yeah, we're hoping that have a positive impact.
Yeah, we haven't had any issues yet with regards to the insurance that we've had to have. That's not to say that we're over all the hurdles. But as Janna said, like, you know, we are increasingly aware of insurers who see this inclusion of data as a positive way of preempting and proactively de-risking these material constructions, which, as someone said, like, to some can be seen as being atypical or unusual, but for those who are familiar with them, that's how we do every project. And we hope that having this data will help kind of like reassure people that these materials, these build-ups, are entirely suitable and perform to the highest standards,
if not better.
I mean, on that front, actually, I just wanted to clarify something you said earlier, Seb, about a moisture content of 60% at one point, which was that the Larsen truss walls then?
Yeah, that was the outer stud in the Larsen truss frame. So slightly lower than the 100% that I saw on one of Ben's slides, which and yeah, it's never where you want it. But I think the reality is, I mean, 2024 was a very wet year. Building timber in the UK, you can do lots of things to proactively mitigate the amount of moisture that the timber is exposed to. The reality is sometimes timber will get wet. The positive thing is, with the sensor, we were able to show. I think if we hadn't had the sensors, I was personally concerned by the idea of putting up the warms at the wood fiber board onto this timber frame that had just got really wet. But I knew the system should work, but having the sensors in there gave me the confidence to be like, okay, we don't need to interrupt the program. We'll be able to see how this responds dynamically as it starts kind of drying out.
But no, that's a remarkable sort of testimony. It's a great advert for breathable insulation and breathable renders. So yes, it's great. Yeah, and I suppose related, I was just, this isn't a timber question. I was just interested in the screw piles, and is there a limit to, in terms of ground quality or wetness of the ground, you know, that slows down or precludes using screw piles in terms of weather?
Moisture of the ground.
Yeah, I just.
Well, it was actually, I think it was only the week before, or a couple of weeks, if that, before they were installing them, that they came out to site to do testing of the screw piles. So they put a couple of screw piles in, and then I think it was a smaller one in the middle, wasn't it? And then they loaded that and measured the deflection using the other two as the kind of yeah. So that was I think based on the ground conditions that were at that time, and that was a very wet time, and they were just load testing at that point. The screw piles are very good at actually dealing with a lot of, generally speaking, with a lot of ground movement and moisture changes, which is one reason we used them. We knew we had clay, which moves a lot with seasons, but screw piles are very good at dealing with that. So they're a good option.
Great. Yeah, what else? I wanted to ask about ventilation. As you know, Passivhaus, and I can hear you. It's a very high performing building. So I just wanted to ask what was doing the ventilation in your house.
So inside the house, we've got a mechanical ventilation heat recovery system, which you've got to have when you're talking about an airtight building. So for context, building regs on a new school is 8. Passivhaus is 0.6, and our building is 0.28. So we've got a highly airtight building. So we've got an MVHR installed. Nothing conventional about that. From a kind of, it's a very tried and tested system, which then delivers fresh air to all the main living spaces and then extracts from the wet spaces in the kitchen. Sorry, not the kitchen, bathrooms and wet spaces. And then about 92% of that energy is kind of captured and transferred into the fresh incoming air into the building. I didn't mention, but we're also monitoring a whole load of other data points. So we've got sensors in for CO2, and moving forward, we'll also kind of do some like lessons learned about the internal environment, having kind of previously spoken about the wall, the fabric.
Great. I suppose I should tell everybody that they can find out plenty more information about the project on that. You have a dedicated site for it, don't you? So I presume if people are interested in more specifics about the materials used, they can go there to find out more.
Online with just to keep up with what we're doing, and there's also opportunities to come and have a look and try out some clay plastering, because we've still got loads that needs doing.
Great. Do you have any embodied carbon information for the whole project? Do you know, or will you at a later date?
We will be. We will be getting embodied carbon, definitely, because that's definitely something we want to share. But we're going to try, I think, doing a kind of standard embodied carbon calculation, which makes assumptions versus also the more accurate data that we've got from the actual way it's been built, so we can make that comparison as well, which would be interesting. But yeah, we haven't got there yet.
Great. So we're past 2 o'clock, so I should probably be wrapping it up there. But as I said, do visit the site for further information. So I'll just say a big thanks to Janna, Seb, and Ben for a fantastic webinar. And yes, thank you very much.